Welcome to the session on differentiation, the product rule. The objectives for this session are to differentiate functions using the product rule. The product rule allows us to differentiate the product of two functions. So, if y equals u times v, then dy dx equals u times dv dx plus v times du dx, where u and v are functions of x. The product rule in function notation is as follows. If f of x equals g of x times h of x, then f dash of x equals g of x times h dash of x plus h of x times g dash of x. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first. We are required to use the chain rule to differentiate y equals root 5x minus 1. So let's solve this. We're going to begin by letting u equal 5x minus 1, because this is the bit that makes it more tricky for us to differentiate y. We can now say that y equals root u, which equals u to the power a half. We therefore have that du dx equals 5 if we simply differentiate u with respect to x, and dy du equals a half u to the power minus a half. Now from the chain rule, we have that dy dx equals du dx times dy du. And so plugging in the different parts gives us that dy dx equals 5, which is the value of du dx, times a half u to the power minus a half, which is the expression for dy du. And since we introduced u, we need to plug in u equals 5x minus 1 as shown, to give us that dy dx equals 5 over 2 times 5x minus 1 to the power minus a half. Now let's take a look at part B. Given that y equals x cubed times root 5x minus 1, find dy dx. So let's solve this. We're going to begin by letting u equal x cubed and v equal root 5x minus 1. This will allow us to apply the product rule to y equals uv. Now differentiating u equals x cubed gives us du dx equals 3x squared. And from part A we have that the differential of root 5x minus 1 is 5 over 2 times 5x minus 1 raised to the power minus a half. And so we can apply the product rule. Dy dx equals u times dv dx plus v du dx, to give us that dy dx equals x cubed times 5 over 2 times 5x minus 1 to the power minus a half plus root 5x minus 1 times 3x squared. We can now tidy this up a little bit. Here's our fraction 5x cubed over 2 times root 5x minus 1. And for the second term, if we multiply the numerator and the denominator by 2 root 5x minus 1, we have this expression here. We can now tidy up the numerator to give us 35x cubed minus 6x squared. all over 2 times root 5x minus 1. And factorising this gives us this expression here. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve part A first. We are required to use the chain rule to differentiate y equals sine 4x all squared. So let's solve this. We're going to begin by letting u equal sine 4x. This implies that y equals u squared. So we have that du dx equals 4 cos 4x and dy du equals 2u. Recall that the chain rule states that dy dx equals du dx times dy du. So we can plug these into the expression for dy dx to give us 4 cos 4x times 2u. And this equals 8 times cos 4x times sine 4x. And now let's solve part B. Given that y equals e to the power 7x times sine squared 4x, show that dy dx equals e to the power 7x times sine 4x times a cos 4x plus b sine 4x, where a and b are constants to be found. So let's solve this. In order to apply the product rule, we let u equal e to the power 7x and v equals sine squared 4x. This of course equals sine 4x all squared. So we have that du dx equals 7e to the power 7x, and from part A we have that dv dx equals 8 cos 4x times sine 4x. Using the product rule, as shown, we have dy dx equals e to the power 7x times 8 cos 4x sine 4x plus sine 4x all squared times 7e to the power 7x. And then factorising gives us that dy dx equals e to the power 7x times sine 4x times 8 cos 4x plus 7 sine 4x. And so we have our expression for dy dx. And in this expression, a equals 8 and b equals 7. This brings us to the end of this session. If you have understood its contents, you should be able to differentiate functions using the product rule. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.